Hi there. Now in this video what I want to do is show you how we can use the hyperbolic identities to solve questions like these ones here. And I'm going to show you also how we can express the answers in terms of natural logarithms. So for this first one we've got to solve 3 cos squared x plus 5 sin x equals 5. And with this, we can convert it all into one hyperbolic function, sin of x, by picking up on the identity that cos squared x minus sin squared x is identical to 1. Let's just put it in here. We're going to be using then that identity, cos squared x minus sin squared x is identical to 1. And if we rearrange this for cos squared x is 1 plus sin squared x. So we've got therefore 3 multiplied by 1 plus sin squared x. Okay, and then we've got plus 5 sin x. And then that would equal 5. And if I expand the bracket, rearrange it, because what we're going to have is a quadratic equation in sin x. If I expand the bracket, we can see we get 3 sin squared x. And then I'm going to have plus 5 sin x. And then I'm going to have 3 here. And if I subtract 5 from both sides, it's going to reduce down to minus 2. And that's going to equal 0. And factorizing this, we therefore have a couple of brackets. We're going to have 3 sin x here, and at the front here it's going to be sin x. And then for the minus 2, it's going to be minus 1 here and plus 2 there. Okay, and that equals 0. And then solving this in the usual way, it leads to sin x equaling 1/3, or sin x equaling minus 2. Now, to get what x is, we need to take the inverse sin to both sides of these equations, so that x equals the inverse sin of 1/3, or x equals the inverse sin of minus 2. Now, so at this point we pick up on an earlier result that I showed you in a previous tutorial, and that was that if we have the inverse sin of, say, x expressed in natural logarithms, this was equal to the natural log of x plus the square root of x squared plus 1. So for this one here, we're going to have that x will equal the natural log then of 1/3, and then it will be plus the square root of all of 1/3 squared, okay, plus 1. And for x equaling the inverse sin of minus 2, we end up with x equaling the natural log of minus 2 plus the square root then of minus 2 all squared plus 1. And if we simplify these, we end up with x equaling the natural log of 1/3, and then here we've got 1/9 plus 1 whole 1, that's 10/9, root that, and you're going to get plus root 10 over 3. Okay, for that one. And then for this last one, we can have x equals the natural log of minus 2, and then this is just going to be plus the root of 5. So there's our answers for that one, expressed in terms of natural logs. Now for this next one, we've got to solve 2 cos 2x equals 9 cos x minus 7. And we pick up on the identity for cosh 2x, being able to express it in terms of cosh x. So we should be familiar with the identity, that is using cosh of 2x being identical to 2 cosh squared x minus 1. And if I substitute 2 cosh squared x minus 1 in place of this first term here, we're therefore going to have 2 multiplied by 2 cosh squared x minus 1, and then that's going to be equal to 9 cosh x minus 7. So I can see that we're going to have a quadratic equation here in cosh x. So expanding the bracket and rearranging, we're going to have 4 cosh squared x. 4 cosh squared x then. We're going to subtract 9 cosh x from both sides. So we end up with minus 9 cosh x. And then we've got minus 2 here, and if I add 7 to both sides, that's going to give me plus 5, and that's going to equal 0. And factorizing this, we end up with 2 brackets, and in those 2 brackets we're going to have 4 cosh x at the front here, 4 cosh x and a cosh x here, and we're going to have a minus 5 and a minus 1. Okay, so that leads on to cosh x equaling 5 quarters, or we would have cosh x equaling 1. That's a nice easy answer, cosh x equaling 1. So to get x, we're going to need to work out the inverse cosh of both sides. So x would equal the inverse cosh of 5 quarters, and we would have, for this one, I said that was an easy one, x equals simply 0 for that one. Okay, now we can express something like this in terms of natural logs. Again, remember from a previous tutorial we said that if you've got the inverse cosh of x, it can be expressed in terms of natural logs as the natural log of x plus or minus the root of x squared minus 1. Remember, when you're solving equations for cosh x equaling a positive value like this, there can be 2 solutions. So that's why we need the plus or minus. So using this, we therefore have x equals the natural log of 5 quarters plus or minus the square root then of 5 quarters all squared. 5 quarters there, all squared, minus 1. And the other solution then was x equals 0. Now when it comes to cleaning up this first term, it works out very nicely actually, because the square root of 5 quarters all squared minus 1 is the root of 9/16, which is going to be 3 quarters. So you got 5 quarters plus or minus 3 quarters, and that leads to the natural log of 2, or the natural log of a half. Or you could write that as minus the natural log of 2. So you could end up with x equaling plus or minus the natural log of 2. And the other solution then is x equals 0. So there we go. Hopefully that's given you some idea then how we can use the hyperbolic identities then to help us solve hyperbolic equations.